Chapter 9, Part 2, Confidence Intervals for Proportions. Think back, in this case, to our binomial distribution. When do we use a confidence interval for a proportion? Well, we use it specifically when we're looking at nominal level data, specifically when we're thinking about qualitative data rather than quantitative data. So here's a few examples. Let's zoom in on. So it says a recent study of married men between the ages of 35 and 50 found that 63% felt that both partners should earn a living. Now, this is 1 point estimate, but we are interested in figuring out the specific confidence interval. The assumptions we make in this case are based on the binomial conditions. So first, remember our binomial conditions include that the sample data is a result of counts, which means we can either have 0, 1, 2, 3, 4, 5, etc. Successes. Each trial has two outcomes, success or failure. The probability of success remains the same for each trial, which means whatever happens in trial 1 has no impact on trial 2. Think of the coin toss. If you get heads in the first coin toss, does it change the probability of what you see in the second coin toss? Right? And second, the trials are independent, similar explanation to part C. There are specific conditions in terms of sample size. In this case, the sample size must be that n times pi, so the number of trials, times the probability of success, and n times 1 minus pi, number of trials times probability of failure, should both be greater than 5, which we'll safely assume for our examples will in fact be true. So what is a proportion? The proportion is a fraction, ratio, or percent indicating the part of a sample or population having a particular trait of interest. In this case, what we're going to be looking at is a survey of 100 individuals, and we want to know how many of them favored the continued use of daylight savings time, and in this case we find 92. So the sample proportion P is equal to X, which is the number of successes, which in this case is 92, times N, which is the number of people sampled, which is 100. So in this case, the sample proportion is in fact 0.92 or 92% of the whole. To develop the confidence interval, we take our sample proportion P, and then we do plus or minus Z, which again, remember, Z is based on the confidence level using the Z distribution that we assessed in the last section, times the square root of the probability of success times the probability of failure divided by the sample size. This section, Z times the square root of P times 1 minus P over N, is still called the margin of error. So in this case, what we found is that the sample proportion is in fact 0.92. Let's go on to a practice question.
The union representing the truck drivers of America is considering a proposal to merge with the Teamsters Union. According to the TDA union bylaws, at least 3/4 of the union membership must approve any merger. So we mean at least 75% must approve of the merger. A random sample of 2,000 current employees members reveals 1,600 of them plan to vote for the merger. So number one, what is the estimate of the population proportion? So remember, the estimate for the population proportion is the sample proportion. And in this case, the sample proportion is 1,600 out of the 2,000 members would vote for approval, which is 0.8 or 80%. Part 2. Let's develop our confidence intervals. Let's start with the smaller interval and then we'll do the larger one. Let's start with the 80% confidence interval. So we're going to start by listing all of our available information. We have that the sample size is 2,000. Our sample proportion is 1,600 over 2,000, which equals 0.8. we're starting off by looking for a confidence interval with the 80% level. And the confidence interval at the 80% level based on our z-table is going to be, recall our process. We start off, we take the 80% and divide it by 2, so we get 0.4. Step 2, we look up 0.4 in the body of z-table, and we find that 0.4 is 1.28 in the z-table. Okay, so let's start by building. So our confidence interval is comprised of the sample proportion plus 0.8 plus or minus z, which is the 1.28 we calculated, times the square root of the sample proportion 1 minus the sample proportion over n, which in this case is 2000. So what is our confidence interval? Our margin of error in this case is 0.8 plus or minus 0.0114. So now to get our actual interval, we do 0.8 plus 0.0114 and then 0.8 minus 0.0114. So the lower range of our 80% confidence interval is 0.7886 and the upper range is 0.8114. So that's our 80% confidence interval. Now let's build our 99% confidence interval. So confidence interval 99%. So what we need here is a new z-value. So the z-value for 99% is going to be, again, let's follow our process. 99% divided by 2, we get 0.495. Step 2, we look up 0.495 in the body of the z-table. Okay, and we get a value of z equals 2.58. Okay, so the confidence interval is going to be 0.8 plus or minus 2.58 times the square root 0.8, 1 minus 0.8 over 2000. So our margin of error is going to be 0.023. Notice the margin of error is larger than our initial margin of error at 80%. So let's put in the lower and upper limits for this confidence interval. So our lower interval is 0.8 minus 0.023, which is 0.777, and the upper is 0.823. Okay, so let's model this on a line real fast and see what that looks like. So here we have a line of all probable outcomes, and let's set basically our requirement to pass this law at 75% or 0.77 in terms of our data here. So what this finds is you have to surpass this threshold in order to pass this law. So at the 80% level, we have quite a small confidence interval that is basically going to be between 0.7886, so we'll say 0.7886 up to 0.8114. And this is going to be our 80% confidence interval. Our 99% confidence interval is between 0.777, so we'll say here 0.77, all the way up to 0.823. So this is 99% confidence interval. Now we can see here, even with a fairly large confidence interval of 99%, right, we can see that we are surpassing this threshold. Therefore, we can say with fairly high certainty that this law or proposition will pass.